Hi guys, this is the video for chapter 10, lesson 5. So in this lesson, we are going to take a look at a special segment. And basically, this segment is called a tangent. And so this tangent that we're describing is not the same as like sine, cosine, and tangent. That's not the same thing that we're talking about here. But basically, a tangent is really a segment that intersects a circle at exactly one point, or a line, right? So it intersects the circle at exactly one point, meaning the place where they cross over is just one location, one point. So it's just barely gliding over, grazing this circle at one point. And where they cross is called the point of tangency. Okay, point of tangency is the name where they cross. So if we have a tangent here, and we could say if I have a tangent going like that, I could have a circle just barely touching it at one point. And then another circle. I know my circles aren't great. Just barely touching it at one point too. So this would be a tangent, a common tangent, because between the two circles. So this would be called a common tangent, where it is, this is a common tangent. This line is tangent to two circles. So if circles share the same tangent, it's called a common tangent. So you could have a tangent like this, and then you could have your circles both like that. That would be a common tangent, right, with those circles. So, you can draw your tangent in different ways and have two circles intersect the same tangent at different points. So if I have a tangent on a circle, just barely touching it, something that's interesting is that wherever my center is, if I draw a segment from the tangent to the center of the circle, okay? So I think this looks like could be the center. I don't know. Yeah. Tangent to the circle. Or from basically drawing a radius or drawing a segment from the center of the circle to the tangent, the point connecting where the point of tangency is. What's interesting is every single time, wherever you draw that tangent, that point of tangency will make a right angle with this segment that is coming from the center. So like the radius, right? So let's just try another one. If I draw I know these aren't perfect circles, but I draw my tangent here, tangent line there, and my center is like right here, and I connect it to the point that they intersect. Doesn't that look like a right angle? I know it's not a perfect drawing, but this is a right angle. So it doesn't matter where I draw that tangent. If I draw it here, as long as they're crossing over at one location, right? From the center to my point of tangency, it is a right angle. So it doesn't matter where I draw my tangent, I'm always going to have a perpendicular line with my tangent and the radius, basically. right? Connecting to where the point of tangency is. It's always perpendicular. So the radius to the point, I guess I'll type this out so you can have this. The radius to the point where the tangent and circle meet will always be perpendicular. Always. Okay. So we like to do a lot of things with right angles. So let's take a look at your study guide. Number 2 here. If you have a tangent, JK is tangent touching, glazing over the circle H. This is the radius. We know that this is a right angle. So when I create these two segments and then I connect H to K, and it says I'm looking for this whole length here. Well, the crazy thing is you've just created a right triangle, and we love using our right triangles, right? So we can find the hypotenuse using the Pythagorean theorem. 15 squared plus 20 squared equals x squared. And you can work it out. Okay, so see what you guys got. 15 squared is 225. 20 squared is 400. Add them together. Square root of 625 is 25. Okay, so x is 25. Great, so let's take a look at number 4. Here's a tangent line. Here's a radius. I know where they connect is going to be a right angle. Looking for x again. Now be careful. This, I think, is saying x as in this distance. I know it's not very clear. So let's say that this x is this distance, u to t. Because if it was, if it was saying the whole entire distance, I think they would draw a long line showing that. So it's only this part. So let's find the hypotenuse first, because that's from r to t. So 15 squared plus 36 squared equals hypotenuse squared. Okay, so 15 squared is 225. 36 squared is 1,296. Add them together. Square root 39. Okay. Square root all that. So hypotenuse is 39. So transfer some information here. If the radius is this length here, well, isn't the radius going to be the same here? So that's 15. So to find x, we could just do 39 minus 15 equals x, and that would be 24. 24, and that's the answer. Okay. We're going to leave these two for now because we'll come back to them. But I want to talk about another thing that we know to be true about tangents. So if you got a circle and the circle has two tangents, but they intersect outside that circle, okay? So they intersect right outside the circle and they both have one point of tangency, because that's what a tangent is. What you will find out is that these tangents will be exactly the same. They are congruent. So these segments are congruent. If two tangents from the same form the same, okay. If two tangents from the same exterior point are congruent to a circle, then they are congruent, okay? So these are congruent here. So let's take a look at our study guide. We've got number 1, BC and DC. Well, I know that these are congruent because they connect at the same point, and we're knowing that these are whatever, it says whatever segments appear to be tangent are tangent. So these appear to be tangent, they're tangent. So I know they are congruent. So x plus 3 equals 7. They are congruent. Subtract 3 from both sides, x is 4. Number 3, if this segment is 12, x would also be 12, right? Okay, let's go back and review a little bit of 5 and 6. So number 5, again, right here, 8 is showing this little segment, so just be careful with that. And it looks like it's saying actually find this part. Ooh, so this might be a little bit tricky, right? So we need to puzzle piece this together. If we know the radius is 21, what's y to a? Well, that's a radius, isn't it? So this is also going to be 21. So 21 plus 8 is 29, which means this whole entire segment is 29. And this is something you kind of have to visually puzzle piece together to figure out. If you don't transfer the idea that the radius can cross over in any direction or anywhere, and this is also the radius, YA is also the radius, then you're going to be stuck, right? So kind of understanding that radius, if you turn it, no matter where it goes, it's the same distance. So now we can find x. This is the hypotenuse. So we have 21 squared plus x squared equals 29 squared. And so we can work that out. 21 squared, 441. Oops, this is plus. 29 squared, 841. So subtract 441 on both sides. 400. Square root both sides, and x equals 20. That's your answer. Great. This one's pretty straightforward, so try this one out. We're looking for this entire length. That's the hypotenuse. This is going to form a right angle. So we have 24 squared plus 17 squared equals x squared. $576. 289. Add them together. 865. Square rooted. Decimal. 29.4. Okay, I believe that's right, hopefully. Okay. Now the next thing we're going to look at are circumscribed polygons. Okay. So we've kind of talked about what a circumscribed polygon is. It's really a polygon that's just drawn kind of on the outside of your circle. But here's the thing, is that all the segments actually intersect the circle at one point, which means all the sides of your polygon are actually tangent to the circle, okay? Which means if they are tangent to the circle, like for this shape, for example, and they intersect outside the circle at the same point, that means that these two segments are the same length, right? And then these two segments are the same length. That's something that we learned about, you know, where segments intersect on the outside. And then these two segments would be the same. And they intersect right here. And these segments would be the same because they intersect right here. So if this were 4, this would also be 4. And if this were 2, this would be 2. And then if this were 3, this would be 3, right? And vice versa. So 2, 2. So then we could find the entire segment. This would be 6, this would be 5, and then this would be 5, and this would be 6. And then you could find the perimeter. If you needed to, you really could. You could add them all up, and that's the perimeter. And the perimeter would be 11 plus 11, 22, right? 22. So let's take a look at our study guide. Really what it's asking us to do is find x and find the perimeter. So we're going to apply the same idea. Really, you're looking at how these are tangent to the circle and that they intersect on the outside. So for example, if this is 13, these two segments are going to be the same. So this is 13, right? If this is 17, these two parts are the same. So this is 17. This is 10 here. This would be 10. So 10 right there. So then x, if we had to find the entire thing, that x would be 23. And then if you wanted to find the perimeter, 17 plus 13 plus 13 plus 10 plus 10 plus 17, right? So you can add them all up and just plug it in, right? And that's 80, I believe. 80 is the perimeter. So P equals 80. Okay, looking here, if I know that this is 18, then this would have to be 18, right? Okay, so then I can backtrack 26 minus 18 is 8. So this part would be 8. This part would be 8 because these are the same. If this is 14, this would be 14. So x equals 8. And then add them all up. And if you know this is 26, that's probably good. Plus 8 plus 14 plus 14 plus 18. And ooh, the perimeter is 80 again. I hope I did that right. So perimeter is 80 again. Okay, same idea here. If this is 8, this would be 8. If this whole length is 16, this is 8, then this would be 8. And then if this is 8, and oh, this looks like a square. From what I can tell, if this is 8, 8, and this is 8, and then 2x plus slash this 2x equals 8, right? 2x equals 8. And so then x equals 4. So this is 8 again. So 8, 8, 8, 8, 8, 8, 8, 8. So 16 on all the sides. 16 times 4. $64. So the perimeter is 64. Okay, I hope you're getting the idea. I don't want to have to do all of these. I think I'll do number 6. Okay, that's what I'll finish on, but try the rest. See if you can figure out all the rest of them. Okay, so if I know that these the segments are the same, that means A equals x plus 2. So if I subtract 2 on both sides, x is 6. That's one of my answers. And if this is 8, this would be 8. And then I can add, oh, this is 9, this is 9, this is 4, this is 4. So add them all up. Oh, 5, 5. So you're finding your pairs there. 8 plus 8 plus 5 plus 5 plus 9 plus 9 plus 4 plus 4. So add them all up. Hopefully I plugged them all in right, but perimeter is 52. Okay, I think you guys get the idea. So hopefully these other two are good, but really you're applying what you know about tangents and using that. That's all you're really doing. Okay, that's all I have for you.